Welcome to Shanti-Peace for Mathematics. In my previous video, we have talked about the linear transformation. The linear transformation is defined as f of z is equal to az plus b, which translate a figure as well as its rotate and its magnifying the figure. So if this a you can write as a e power I theta 1, a into e power I theta 1, then the amount of a, it's depends on how much magnification is there. If a is greater than 1, then it is the magnification, that means it stretch the figure, and if a is less than 1, then it has to be contract the figure. The amount of theta is depends on how much rotation of the shape is there. So whatever the value of theta is, that figure is rotated by the angle theta 1. That sort of things we have discussed in our previous video. In this video we are talking about the inversion transformation. So the inversion transformation is defined as W is equal to 1 upon Z, is establish a 1-1 correspondence between the non-zero points of Z plane and the W plane. Since you have Z into Z bar is equal to mod of Z bar square, this mapping is also can be written as Z, which is Z upon mod Z square, if W is written as W can be written as Z bar, because this I can write as Z bar upon Z into Z bar, so that is Z bar upon mod of Z bar square. So if I take Z bar, that is Z upon mod of Z bar square, so this is written in that form also. So this transformation W is equal to 1 upon Z is inversion with respect to the unit circle mod Z is equal to 1. That is the image of non-zero point Z in a point Z with property that the modulus of this Z is same as 1 upon mod of Z. So the modulus will inverse the argument of capital Z, that is this, is the same as the argument of small z, that is x plus I. Thus the point of exterior to the mod Z is equal to 1 are mapped onto the non-zero points interior in it, and any point on this circle is mapped itself. So if you have any point on the mod Z is equal to 1, that maps the itself. So let us see this is by the figure. So if you have, this is the mod Z is equal to 1 in Z plane, so whatever the points are inside this circle, that maps outside to this circle, and those points which are outside, that transform to the inside to the circle, and those points are onto this circle, that points are transformed to the onto this circle under this inversion transformation. Let us see this is with analytic way. Let us Z is equal to R e power I theta if you assume, and this W I assume that capital R e raised to I phi, and if I use this expression W is equal to 1 upon Z, that will implies capital R e power R phi is equal to 1 upon R e power I theta. That will implies capital R is 1 by R and phi will be minus of theta. Now under this transformation, any point P of R theta is there in Z plane, that transform to the point P dash, which is 1 upon R minus theta in W plane. Let us superimpose a Z plane and onto the Z plane W plane. Here let us try to draw. This is, I am just drawing a first Z plane with the, I am just drawing, this is the circle. Suppose this is the point R comma theta, and this is your x axis and y axis is there. I am also writing this is as u axis and v axis. So what we are doing is we are superimpose the W plane onto the Z plane. Now let us try to plot this point, that is P dash of 1 upon R minus theta. So this point is actually, let us say it is 1 upon R theta, and we are calling it is P1 of that. So minus theta will be here, you will have. So this value is 1 upon r minus theta, that is your P1. So the image of this point is this, and if this is your theta value, this has to be also a minus theta if you go into the reverse direction. This is in this direction. Thus this W is equal to 1 upon Z is the inversion of a Z with respect to the unit circle. Z is equal to 1 followed by the reflection, the inversion into the real line. So whatever the point is there on here, that's a reflect with respect to x real axis. Okay, so that is the reflection inversion transformation is there. Let us solve some of the examples into this. Discuss the image of x square plus y square plus 2gx plus 2fy plus c equal to 0 under the transformation w equal to 1 upon z, where g square plus f square minus c is greater than 0. So what is this represent? First of all, you should know that in general this equation with this condition is represent the circle. So here the question is to calculate what is the image of a circle under this transformation. W is equal to 1 upon z, that is inversion. Since these values are given in terms of x and y, I need to have what is the value of x and y. So that's W is equal to 1 upon z is there. That can be written as z is equal to 1 upon w. And if you can write down z as x plus iy and w as u plus iv, if you multiply and divide by its conjugate here, you will have this is u minus iv upon u square plus v square. So therefore the value of x, you will have u upon u square plus v square, and the value of y is minus v upon u square plus v square. The question is to calculate what will be the image of x square plus y square plus 2gx plus 2fy plus c equal to 0. Now we have the value of x and y here. We will substitute here. That is u upon u square plus v square whole square minus v upon u square plus v square whole square 2gx, that is u upon u square plus v square plus 2f minus v upon u square plus v square plus c equal to 0. If you simplify this, you will have this is u square plus v square upon u square plus v square whole square plus 2g u plus 2vf, but this has to be minus upon u square plus v square plus c equal to 0. This one u square plus v square is cancelled out, and then you will take the LCM. You will have this is 1 plus 2gu minus 2vf plus c into u square plus v square equal to 0. Now there will be two conditions under which this equation represent, which we need to find out what this equation will represent. Now if this c is 0, then this equation will become 1 plus 2gu minus 2vf equal to 0. That means this is in w plane represent a line. On the other side, the equation in xy plane will become x square plus y square plus 2gx plus 2fy equal to 0. This will represent the circle, and this circle is passing through origin. This line is does not passing through origin. So if you can see, if any circle which passes through origin in z plane, that transform to a line not passing through origin. So this is under the transformation w is equal to 1 upon z you will have. So here the circle passing through origin, the image of that is a line does not passing through origin. If c is not equal to 0, then you will have this equation can be written by dividing c both sides. You will have this is 1 upon c plus 2g by cu minus 2fc by v plus u square plus v square equal to 0. Now this will represent the circle if this term square plus this term square minus this will be greater than 0. So let's calculate that. That is g square upon c square plus f square upon c square minus 1 upon c. That will be g square plus f square minus c upon c square, and g square plus f square minus c is already greater than 0. So this has to be greater than 0. That means this will represent the circle with center minus g by c plus f by c, and the radius will be this much, square root of that. So with that we can say that in the z plane on the other side, it is also a circle x square plus y square plus 2gx plus 2fy plus c is equal to 0. So this c is non-zero. So the image of that one is this circle. So we have here the circle which is not passing through origin. So here somewhere this is the circle. The image of this circle is also a circle which is not passing through origin. So it may happen that your circle will be this. The image of this one is this. Under this transformation, w is equal to that. So what we can note is, under this transformation, circle does not passing through origin map to circle does not passing through origin. That we can note. So the question was to find out the image of that circle. So the image of the circle is depends on the value of c. If c is 0, that means the circle is passing through 0, then its image will be line, not passing through origin. And if the circle is not passing through origin, the image is a circle not passing through origin. Let us have the next example. Discuss the image of the line ax plus by plus c equal to 0 under the map w equal to 1 upon z. Here we need to calculate what is the image of this line under this map w is equal to 1 upon z. So in the previous example we already discussed that the value of x is u upon u square plus v square, and the value of y will be minus v upon u square plus v square. So we'll have this value, we substitute that value into this, so that we have it is u upon u square plus v square. So from this, by substituting value, we'll have b minus v upon u square plus v square plus c equal to 0. If you take the LCM as u square plus v square, we'll have this is au minus bv plus c u square plus v square. Here is also we have a same case, because if the value of c is non-zero or 0, it may depends on that. What does this represent? If c is 0, then you will have it is au minus bv, which is 0, which is a line passing through origin. So on the other hand, you will have a line that is ax plus by, which is 0. So the line passing through origin maps to the line passing through origin. So you will have, this is the things, a line which is passing through origin here. So you will have a line which is passing through origin. So this is under the map w is equal to 1 upon z is there. So line passing through origin maps to line passing through origin. That we can conclude from this. The second one, c is non-zero, then you will have au minus bv plus c into u square plus v square, you will have equal to 0. You just divide by c, you will have a upon c u minus b upon c v plus u square plus b square is equal to 0. This will represent a circle if this quantity square plus this quantity square is greater than 0, and which is already greater than 0, because a square plus b square upon c square is that this quantity is always greater than 0, because a square plus b square is never 0. If it is both of them are 0, then this equation ax plus by plus c does not have any meaning. So that's why this a square plus b square is not equal to 0, and this is always positive. So that's why it is always greater than 0. And so this will represent the circle which is passing through origin. The image of a line which is not passing through origin is the circle passing through origin. So the line does not passing through origin is mapped to, under the w equal to 1 upon z, is circle passing through origin. So what we conclude by this, we conclude that if a line which is passing through origin, it's mapped to a line passing through origin. If the line does not passing through origin, it's mapped to circle passing through origin under this transformation w is equal to 1 upon z. Let's move forward to next example. Find the image of x square plus y square greater than 1 under the map or a transformation w is equal to 1 upon z. So here is the question is to calculate what is the image of x square plus y square greater than 1. Let us try to see that. The x square plus y square greater than 1 is actually represent the exterior part of a unit circle. So this is the unit circle you will have, and x square plus y square greater than 1, the radius of this circle is 1. The exterior part of that is represented by this region, and the given is w is equal to 1 upon z as a map. You note that this x square plus y square greater than 1 I may also write as mod z is greater than 1 if I can assume that z is equal to x plus iy. Now this will gives you z can be written as 1 upon w, so that's why this is 1 upon mod w greater than 1, so that will imply is mod w is less than 1. If w is equal to u plus iv, then this will represent u square plus v square is less than 1. So that means this is represent the disk with the radius 1. That means the image of this one, you will have a unit disk which is inside portion of that. So this is nothing but the u axis and v axis. So this portion is u square plus v square less than 1. So the image of this outer portion is this inside 1 under the map w is equal to 1 upon z. Let's have more examples. In the above example, just include one more extra condition into it. So let us calculate what is the image of x square plus y square greater than 1 with x and y is positive. So this example is remain same. Just with this condition we are adding one more condition, that is x and y is positive. X and y are positive, that means it is in first quadrant. So you will have, this is the graph of this region is given, that is x and y are positive, that means it is this curve with x axis and y axis are positive. So that means the region is given is outer portion of this quarter circle into the first quadrant. Now into the image of this one we already calculated here, that is u square plus v square is less than 1. Now to image of this portion, that is x is positive, the value of x we already calculated is u upon u square plus v square is greater than 0, that will imply u is greater than 0, and y is greater than 0 will imply minus v upon u square plus v square is greater than 0, that will imply v has to be negative. So the image of this y greater than 0 is v less than 0. This is your z plane. Now we are calculating a w plane, that is u positive and v negative. U positive, that is here, this is your u axis and this will be your v axis, and v negative it is in this. So that means all the region is come into the third quadrant, and with this condition u square plus v square is less than 1. So that means you have, this is your curve which is the image of this outer portion is this inside 1 under the map w is equal to 1 upon z. So this is the image of this one is this with this and this. So that's for the image of this region. Let's have next example. Next example to calculate what is the image of 1 by 4 less than or equal to y less than or equal to 2, that is the infinite strip you will have. Let us try to plot this infinite strip. So if this is considered your x and y axis in this manner, and y is equal to 1 by 4, y is equal to 1 by 4, that means this is the line you will have, y is equal to 1 by 4. So this is your line y equal to 1 by 4, and that is another line is y is equal to 1 by 2. The area between these two is this. Now we need to calculate what will be the image of this. So as you know that the value of y under the map w is equal to 1 upon z, we already calculated it is minus v upon u square plus v square. So if you substitute this value here, so let us calculate what is the image of y equal to 1 by 4. So that will gives you minus v upon u square plus v square equal to 1 by 4. that will implies minus v into 4 equal to u square plus v square. So that means this is u square plus v square plus 4v plus 4 equal to 4. Just I am adjusting this 4 here by making the last term of this 2, because I want to make it is a perfect square. So that's why it is u square plus v plus 2 square equal to 2 square. So what is this represent? It's represent the circle with center 0, minus 2 and the radius is 2. So the image of this line, let us try to plot that, is a circle with center 0, minus 2. Center is 0, minus 2 is there, and the radius is 2. So that has to be touch u. This is your u axis, this will be your v axis, and the image of this line is this that you have. The another one is y equal to 1 by 2. If you calculate in the similar manner as we did here, so this is v upon u square plus v square equal to 1 by 2. By simplifying, you will have u square plus v square plus 2v. I'm adjusting 1 here, so that's why it is u square plus v plus 1 square equal to 1. That means it is also represent the circle with center is 0 minus 1 and the radius is 1. So that is represent a circle with center 0, minus 1 and the radius is 1. So that's why it is this circle. Now here the question was y 1 by 4 less than or equal to y less than or equal to 1 by 2. That means the area which is bounded by this 2. So here the area will be bounded by this 2 circles. The area between bounded by this 2 circle means this is the area you will have under this map. You can note that the image of this area will map to this bounded by these 2 circles. Let's give you one more example. Find the image of the strip 0 less than y less than 1 by 2 under the map w is equal to 1 upon z. So in the similar manner, let us calculate what is the image of y equal to 0. As we have already calculated the value of y into the above, that is the value of y in terms of uv is minus v upon u square plus v square. So this will gives you minus v upon u square plus v square equal to 0. So that will gives me v is 0. That means the image of line y equal to 0, that is x, is v equal to 0. This is u axis, which is your v equal to 0 line. So the image of this line is this line. Now the another one is given y is equal to 1 by 2, that we can calculate by minus v upon u square plus v square is equal to 1 by 2. That we can write as u square plus v square plus 2v equal to 0. So you can have u square plus v plus 1 square equal to 1. So this will represent the circle with center 0, minus 1 and the radius will be 1. So the image of this y is equal to 1 by 2 line, y equal to 1 by 2 line is here, that you can see. The image of this line is here, that you will have 0, minus 2. Hence the area between these 2 line is mapped to the area of this circle, inside the circle that you can have. So what we can note here is a line which is x-axis, which transform to a line which I can treat it as a circle with the infinite radius. Line is transforming to the line, but I can treat them as a line with the infinite radius. Now there are a couple of examples I like to give you as a homework. So try to calculate what will be the image of 1 by 4 less than or equal to x less than or equal to 1 by 2 under the map w is equal to 1 by z, and try to calculate what will be the image of z minus 3i equal to 3 under the map w is equal to 1 upon z. So in this video we have discussed about the inversion map. The inversion map is defined as w is equal to 1 upon z, and the point of exterior to the circle mode z is equal to 1 are mapped onto the non-zero points into interior point of the z, and the conversely, that means the interior point is mapped to the exterior of the point, and any point on the circle is mapped to the circle itself, and also it transforms the reflection with the real axis. So with that note, I'm stopping here for this video. If you like this video, please press the like button. If you have any comment, suggestion or question, please drop down in a comment box below. Till then, bye bye, sayonara.